Hello everyone, today in this video we'll be discussing the module 1 of cloud computing 6th semester subject BCS601, and in this video we'll be discussing all the things which you need to know in from the exam point of view to score more than 80% marks. And the topics are more and the theory part is also more, but I'll be simplifying it and just telling you that which you are required to learn to score nice marks in exam. Okay, so before starting, please do like and subscribe. It helps me make more videos like this. And if you have any questions or doubt, you can DM me on Instagram. This is my ID _AFUU. Okay. So the first topic is scalable computing over internet. Basically, there are 5 topics. Okay, 5 major topics are there. Inside each, there are few subtopics. Okay, so I'll be going through each of these topics, and you'll be easily able to understand. Okay, so listen carefully. First is scalable computing over internet. Okay, in these 3 subtopics are there. We'll discuss what all you need to know from this topic. Okay, scalable computing over internet means that when the internet is expanded, more data is present. Okay, the internet is expanded, more data is present. To store that data, we are using a cloud architecture. Okay, we are using it to store the data from all over the world. Okay, now as the scale increases, we have to store more and more data, and more processing is required. For that, more computation is required. Okay, more computers are required to process the data, and they should process very fastly. Okay, so what are the techniques we have to ensure that computer processes the data more fastly? Okay, so first let's learn about the age of internet computing. Okay, so the age in which we are living is the age of internet computing, because basically most of the things what we do in our daily life is related to internet in some way or the other way, right? The trend and need has moved from high performance computing to high throughput computing. Okay, two things are there you need to know, very important from the exam point of view: HPC and HTC. Okay, HPC is the high performance computing and HTC is the high throughput computing. Performance computing was required initially when internet came, right? Everyone were more concerned about how fast we are getting the responses from the internet. Okay, that was the criteria. So everything was revolved around the high process computing, whichever gives the more faster results. That was the thing which is considered. But now what happened, this reached a limit. Okay, this reached a limit where we are getting very instant results. Okay, now the thing is high throughput is required, because there are billions of users worldwide. Okay, worldwide, what is there, what are the billions of users are there? To all of the users, the results has to go. Throughput means how many users the result is reaching to. Okay, that is called as throughput. How much output we are getting, the number. Okay, this is the speed and this is the number, how much large results we are able to compute. Okay, that is the thing. Now this is the main concern, because we are focusing more on how many people we are able to reach using the internet, okay, fastly. So the trend and need has moved from high performance to high throughput. Whichever the thing is giving us high throughput, that will be considered in today's era. Okay, that's the first thing. Now the internet was not always like this. It has gone through generations. It started from 1960 and it is developed till now. The first generation was IBM 360 and CDC 6400. Okay, the second generation, whichever the things came, those have lower cost mini computers. Okay, they were mini computers from 1960 to 1980. Then came personal computers in between 70 to 90. Okay, then came portable computers, which were the mobile devices, that came in 1980 to 2000. Okay, and fifth generation is now, which we are currently concerned with, the HTC and HPC. Okay, so this is the diagram you need to remember. The HTC systems are concerned with the distributed control, because we have to give the access and the resources to many people worldwide, right? So different people are present here. That is called as distributed. Okay, and this peer-to-peer network. Each of these devices connects with each of the other devices. That is called peer-to-peer network. Okay, so it is in geographically sparse. If you consider the HPC, here the main thing is the high speed and it is centralized control. One place will be there where all the processing will happen. Clusters or MPPs will also be there. Okay, and these all merge into computational and data grids. This topic will be discussing in depth in the upcoming topics. Okay, and this is divided into 3 parts: service oriented architecture, virtualization, and internet of things, IoT. Okay, we will discuss each of this in the depth. For now, just remember that this is the diagram for HTC and HPC systems. Okay, next, in the above figure, there are 3 new paradigms of computing. Okay, these 3 paradigms I'm talking about. These 3 paradigms of computing are there. Okay, and this I have emerged from computational and data grids. Okay, from the computational and data grids, it is merged. Okay, and there are 4 definitions you need to know. What is centralized computing? Centralized computing means it is a paradigm in which all computing resources are centralized in one physical system. all the resources which are there, all the things which are required to run a computer, that will be present in one place. Okay, so all will be present in one place. This is called as centralized computing. Okay, next is parallel computing. Parallel computing means there are different computers present at the same time they will be running. Okay, different computers same time they will be running. That is called as parallel computing. Third is distributed computing. Distributed computing, where the tasks are distributed across various computers. Suppose one big task is there, you have to perform it. This is divided into smaller tasks. Okay, and each of these smaller tasks is given to a different computer. So every computer will be having small tasks, and at the end all of these tasks will be merged, and this will be the final result. Okay, that is called as distributed computing. The last one is the cloud computing, where we utilize the cloud resources, where the data and the computation happens over a cloud. Okay, so these are the four types of computing you need to know. Okay, these are the four different types of computing definitions you need to know. Next is, as time progresses, HPC and HTC will require more parallelism and distributed computing. Okay, because a single computer cannot handle such high performances and such high throughput. So that's why parallelly different computers should handle it. Okay, so two concepts come into consideration here, which is parallelism and distributed computing. Okay, to achieve the parallelism and distributed computing in HPC and HTC, four goals are need to be met. Okay, how many goals are there? Four goals. It should be efficient. Efficiency should be there. Dependability should not be there. Adaptation should be there. If any changes come, it has to adapt. Flexibility should be there. It has to adjust and work with different kind of environments. Okay. Next one is scalable computing trends and new paradigms. Okay, see, now distributed systems, you got to know what is distributed system. A main task is that is divided into different parts. Each part is assigned to a computer and they perform it parallelly. Okay, that is distributed system. But how much it is related to parallelism means how many tasks are performed parallelly, at which levels they are performed. So basically there are 5 levels. First level is the bit level parallelism. The bit level computation which is there, parallelly different bits can be handled. That is bit level parallelism. If it is happening at the instruction level, means multiple instructions are being executed at the same time, that is instruction level parallelism. If it is happening at the data level, it's data level parallelism. Next comes task level parallelism. The last is the job level parallelism. Job includes all the tasks which are present that as a single job, and if multiple jobs are being performed at the same time, that is the highest level, which is the highest degree of parallelism in the distributed computing. Okay, everything comes and reaches to a job. Okay, whatever the task is there, like if you open Instagram, you'll be seeing a post, right? That is a job. Due to a job, that post is seen. Okay, like that many people are seeing that post. Okay, so it has to come to multiple devices at the same time. That is called as parallelism. Okay, and where all these things are used, high performance and high throughput systems, basically they are used in the science and engineering. Okay, like scientific simulations, genomic analysis, earthquake prediction, global warming, weather forecasting. If you come to the business and education side, we'll be having to do with the e-commerce, transaction processing, stock exchanges, air traffic. Even in healthcare it is used for the hospital automation. Then comes the internet and web services and government applications. This we are using it, like internet searches, data centers, decision making systems, cyber security. And last is the mission critical, which is the military command control, intelligence system, crisis management, and tax return processing. All these things are required to have high performance and high throughput system, because many people use it and the results are to be expected very fast. Okay, another thing which you need to know is the utility computing. It means that people pay for services. Okay, see, paid service provider, we are paying for some service, that is called as utility computing. We are utilizing some computation resources and paying for it. That is only called as utility computing. The diagram is here. All these paradigms and services come under technological convergence when it is combined with reliable and scalable, dynamic and discovery, and QoS, quality of service, and SLS. Okay, and HTC in business and HPC in scientific applications. Throughput is needed in business because multiple users will be there. To satisfy all of them, HTC is used. Throughput is more important. HPC is more important in scientific applications. Here only few people will be there. Who will be there? The scientists will be there. They are not 100 scientists. There are very few scientists, right? So throughput is not an issue there. There we have to have more fast processing to get the results faster. So based on the requirement, you will either go with HTC or HPC. Okay, so I hope you got to know a clear difference between HTC and HPC. Okay, very important question from exam point of view. The below diagram shows hype cycle for new technologies. See, understand this as a new iPhone comes. Okay, if new iPhone comes, everyone will be what crazy behind new iPhone. Okay, so everyone will start buying and it will reach a point where it is maximum sales will be there. Then what happens? People will start observing that iPhone is same every time. Okay, so what will happen? People will stop buying. Okay, and it will come to a least sale point. Okay, so when it is in least sale point, it will then gradually come to the actual point. What is its value? Okay, So like that it happens. Every new technology it comes, everyone will be crazy behind that one. Okay, then comes the downsides of it, so it will stop using. Then after some gradual point of time, it will reach to its original value. This is the hype cycle for new technologies. Okay. Next is the Internet of Things. Okay, IoT. IoT means what? In our daily lives, many things will be there. In that, if you want to include sensors and everything to automate all of this, by using a phone, you can control the light, fan, and heater, cooker, everything. Okay, that is called as IoT. Sensors will be attached there, and you can control using a phone. And the cyber physical systems is nothing but the interaction between the processes and the physical world. Okay, so I'll discuss what it is. IoT refers to the networked interconnection of everyday objects, tools, devices, or computers. Okay, so different places where IoT can be used. It can be used in the energy engagement, okay, in grid automation and wireless grid communication. It can be in the wearables like the smartwatches. IoT can be used in the home appliances like refrigerator, coffee maker, and water heater, air conditioner. It can be used in the agriculture. It can be used in the cars. It can be used for the smart manufacturing. Okay, and in the transportation also it is used very much, and in the healthcare to check the blood pressure and the monitor. And smart homes, it is used for the smart home door lock, smart bulb, smart thermostat. And if it is expanded, it can be even used for the smart cities, where the whole distribution and the management can happen for the whole city. Okay, that can also be done using IoT. So this is called as IoT. What is cyber physical system? It is a result of interaction between computational process and physical world. This is the computer, this is the physical world, interaction between them, that is called as cyber physical system. Okay, moving on to the second topic out of five topics. The second one is technologies for network based systems. Okay, now we are learning about the systems which are network based. Okay, based on the network, all the resources will come, input and output will happen based on the network. Okay, so few things are there. We'll be learning about the GPUs and all. It's a very interesting topic. So let's continue. The multi-core CPUs and multi-threading technologies. Okay, what is a CPU? CPU is nothing but it will perform the task. Okay, it will be having some things here. In these things, the questions and answers will come from. That is called as a CPU. Okay, multi-core CPU means every core will be handling something. So, okay, and if multiple cores are there, that will be the multi-core CPU. Okay, this will be handling the questions and the answers will come from here. Okay, that is the multi-core CPU. Multi-threading means what? Each core will have some threads. Okay, if multiple threads are present, that is called as multi-threading. And this has improved over the years. Previously very less computing was there. Okay, now it can handle very much computing. Okay, that is called as processor speed and network bandwidth. How much data can be sent in the internet? That was very less previously. It was like 0.1 MB, but now it is in GBs. Okay, 100,000 MBs per second. Like that means 100 GB, right? 100 GBs can be transferred within 1 second. Previously it was 0.1 MB. Okay, so like that, as the year progresses, it has increased. Okay, so it can be observed that over 33 years, limit of CPU has been reached. Okay, means the limit of CPU has been reached. We cannot improve CPU more. Okay, because CPU, the maximum limit it has been reached. If we try to improve it further, what will happen is we'll get the downsides. Means heating issues will come. If CPU will try to improve it more, the heating issues will come. Okay, it has reached the limit based on CMOS based chips due to power limitations. It cannot handle more power than what it is currently. So we need to have something else, something new. That is the GPU. We will be moving now from CPU to GPU. GPU can handle much more powers, 100x more than CPUs. Okay, how it happens we'll discuss now. Okay, so the trend is shifting towards GPUs. And before going to GPUs, let's understand what is multi-threads. Okay, multi-thread means different programs will be there to execute different programs at the same time. See, this is thread 1. Okay, thread 1, thread 2, thread 3, thread 4, thread 5, and this is idle. Okay, means nothing is executing at that point of time. Now, whichever system executes more things at the less time, that is the better system. As you can see here, there are many blanks also present. Okay, this is 4 issue superscalar processor. This processor, as time processes, only thread 1 is getting executed. That is the worst system. In fine grained multiprocessor, many are executing, but still many spaces are present here. Coarse grained multi-thread processor, it's still better than this one. Few spaces have been reduced. Dual core will have two things. Here only black will be executed. Here only black spots will be executed. Means thread 3 and thread 4 will be executed parallelly. Okay, and here also blanks are there. The best one is SMT processor, where many things are getting executed and it has the least amount of black spaces. Okay, so this is the best one, SMT processor. So this is the thing of multi-threading. Okay, multiple threads will be executed simultaneously. Okay, and what is GPU? Okay, GPU offloads CPU from intensive tasks by having many cores. See, CPU has suppose 6 cores. Okay, it can execute 6 things at a time. GPU has 100 cores. Obviously, GPU will execute more tasks in the same amount of time. So a typical CPUs is worse than a GPU. Okay, unlike CPUs, GPU have throughput architecture utilizing massive parallelism. Parallelly, these things will be executed. Okay, all the cores will be executing the things parallelly. Okay, how does a GPU work? It has 128 cores on a single chip. Okay, just a single chip of GPU has 128 cores, and each core has 8 threads of instructions. In each of these 128, it has 8 threads. Okay, 8 threads will be executed parallelly. So 128 into 8, that is 1024 instructions happen at the same time. So imagine how fast it will be. The previously CPU was just 6, now it is 1024, 1000 times difference, right? So what happens is, if CPU and GPU have to work together, GPU will be processing and giving the result. That result will be going to the main memory, and CPU will be taking that result and giving the output. Got the point? The intensive tasks are performed here, the small tasks are performed here. Okay, this diagram you need to make if they ask about the GPU. Okay, and this figure shows how it is used along with the CPUs. Now you might think that if it is having more core, more computation, it will be more costlier. It is actually reverse. It is not more, it is less costlier. 1/10 of the CPU cost it is. Okay, it consumes only 1/10 of the energy of CPU. That's how it is designed. Okay, something secret is there inside GPU, due to which it is so fast and it is having so much data processing capability, and the energy consumed is also less. Okay, it is a double benefit. Okay, so that is what a GPU. Okay, now memory, storage, and wide area networking. Memory also has increased previously. Previously only 64 KB was a flex. Like if someone has 64 KB SD card, they will be the hero, right? But now it is 64 GB and it is gone in TBs. Okay, this is just about memory chip. Disk capacity has gone in TBs. Okay, so as you can see here, it has increased over the years. Okay, that is the memory and storage. It has increased over the years. Now, if the servers are large, network storage is also large, and the client and host are also very fast. The combination of each of these form the things. Okay, this is the network area storage. If these both are combined, it is LAN. Okay, local area network. If these both are combined, it is storage area network. Okay, like that it is different domains will be formed. Okay, next, what is virtual machines and virtualization middleware? Now, what is virtualization? Virtualization means accessing and using different operating systems. Okay, using the different operating systems from different parts of the world in one system. That is called as virtualization. Suppose my friend has a Mac and another friend has Linux and one of my enemies has Windows. Okay, so I can use all of these things in my single system, which is the Nokia. Okay, that is called as virtualization. Okay, so this is a physical machine where hardware and OS will be there, application will be running, and native VM will have VMM, which is the hypervisor. A guest OS can be used. Okay, my friend's OS can be used. If it is a hosted VM, we can host the OS to some other one who can use it. If it is dual mode, it can both host and it can both use. Okay, the guest can also be used, Mac can also be used here, and if I have Linux, I can provide Linux to other operating systems. That is called as dual mode VM. Okay, it is both giving and taking. Okay, what is virtual machine? Virtual machine approach offers hardware independence of OS and application, because the hardware is present in my friend's home and I am using the his Mac in my home, right? That is the hardware independence. Got the point? And VM is built with virtual resources managed by a guest OS. Okay, guest OS is the one which I am using. My friend's OS is called as guest OS, and my OS is called as a host OS. Okay, between VMs and host platform. Okay, this is VM, this is host platform. In between them, what is there? The sandwich is there? No, you stupid. The sandwich is not there. What is there in between is virtual machine monitor. Okay, in between virtual machine monitor is there to handle both the VM and the host OS. Okay, and there are four operations of VM. Okay, the first operation is multiplexing. Okay, multiplexing means from many to one. Okay, many things can be put here and in one system it can be used. That is multiplexing. Suspension means if one is a useless one, it can be taken inside and it can be used. Okay, provision is from inside it can be taken and used outside. Live migration means from one to other it will be migrated so that all the functionality of this can be used in a different VM. Okay, that are the four operations. Data center virtualization for cloud computing. The cloud computing costs have increased. Okay, see, the virtualization means what? Virtual computers we are installing. This is the cost for virtual computers. Okay, this is the upper line which you can see. This much we have spent in billions for virtual computers, and this is the actual computers which we have, and this gap is there. Suppose everyone wanted to use virtually, it will not be possible. This much gap difference will be there. Okay, this is our target to reach the actual virtual level which we are planning to achieve. Okay, and this is the different cost like power and cooling expense, management cost, and server spendings. Okay, and most of the companies use x86 only because it is cheaper and it is easier. Okay, easier to install. And cloud computing, main four things are there: hardware virtualization, utility and grid computing, SOA, Web 2.0 and WS mashups, autonomic computing and data center automation. Okay, these four things we'll be discussing in the upcoming topics. Okay. The third topic among the five topics is system models for distributed and cloud computing. Now we have learned a lot about the distributed computing and cloud computing. Now we will see what models are used. Okay, basically four types of models are there: cluster model, grid model, peer-to-peer, and cloud computing. Let's understand what you need to remember from each of these. Okay, this is the what is this called table. This is the table which you have to remember. Okay, so architecture, network and size and connectivity for cluster computing, peer-to-peer computing, and grid computing and cloud computing. For this, what is the architecture of each of these? Okay, so in cluster computing, the architecture is network of computer nodes interconnected by LAN, SAN or WAN. Okay, here in clusters, how it is connected by using SAN, LAN or WAN. In peer-to-peer, how it is connected by using a network. In grid, how it is connected by using high speed network. That much only you have to remember. Okay, if you try to remember all of this, you will forget everything and you will fail in exam. Okay, so don't try to remember all of this. It very much is there to remember, so try to remember as less as possible. How much I am telling, that much only remember. Okay, cloud platforms, how it is connected? It is connected using SLA. Okay, that's all. It is connected using SLA. If someone asks you how is cloud platform connected, you say it is connected using SLA. If they ask SLA, slap them and move from that place. Okay, next is control and resource management. Okay, control and resource management, how it is controlled, where all are the control happening for each of these things. Okay, for the cluster computing, the control is happening in the distributed control running in the Unix or the Linux. In the same system, the control happens in the clusters. Each cluster will have its Unix or Linux where it will be controlled. Okay, here it is autonomous. In the peer-to-peer, it is autonomous and free in and out and self-organization. Here it is centralized. Somewhere it will be present. Here all the control will happen, the resource controlling. And in the cloud platform, it is dynamic. Wherever it is required, there the control will happen. Next is application and network centric services. It is high performance computing. The clusters is very high performance computing. Okay, large performances will happen in the cloud computing. And this is related to business applications, the peer to peer. The grid application happens in the supercomputing global problem. Cloud computing happens in the computing. Okay, that's it. And these are some of the operation system, can go through it. Okay. Now, since we have discussed each of these in the detail, I'll not be going through the depth in this. You can go through the depth here, but I will be telling you the key points what you need to write. In cluster cooperative computers, what happens? There are different clusters. Okay, each of these servers are present, and this is called as a one cluster. Okay, and each of the server gives its input and output for this one, and all of this combined together, it goes to the internet. Okay, all of the server gives its input, it will be combined and go to the internet, and the network layers used is the SAN, LAN, and NAS. That's it. Okay, and there is an issue that cluster wide OS cannot be implemented because complete resource sharing is not available yet. Okay. Next is grid computing. In grid computing, what happens? Along with the computer, other things also come. What are the other things? Software and middleware, special instruments, people, sensors together. Okay. All of these things come along with the computer. That is called as grid computing. Okay. It offers constructed across the LAN or WAN. It is also considered across LAN or WAN. Internet backbone is also there. So grid family includes all of the other components as well along with that. Okay. Previous computer grid computer cluster, how it was? Just the computers. Here along with that, other objects and people and all are also coming. Okay, that is called as grid computer. Okay. Third one is a peer-to-peer. In peer-to-peer, every node acts as both a client and a server. Okay, here nothing is separate client and nothing is separate server. All of it is a server and a client, and each of the node will have some data about the server, some data about the client, and whichever data about the server is available, and if another client requires it, it can take from this one. Okay, node to node connection is there, and two layers are there here. Okay, first is the overlay network, where we see like it is a magic happening and all. It's not a magic. Okay, it is what physical links are present in the IP network layer. Okay, we just, it is hidden from us here. Okay, so we'll be able to not see these things, but actually it is connected. Okay, so this is the overlay, and there are two types in that: structured and unstructured. Structured means all the policies will be followed there. Unstructured means it will be just throwing the data and someone will be taking like that. Okay, very chaotic. Okay, and P2P families are there. Four types of P2P are there: distributed file, if you are concerned with the files like MP3, music, video; collaborative platform for messaging and all; distributed for the scientific exploration; and P2P platform for open network public resources. Okay, four types of P2Ps are there. And P2P is also not free of challenges. Hardware and software network requirements are there. Okay, three requirements are there: hardware, software, and network requirements. There are too many hardware models and architectures to select from. Okay, we are getting confused. If 100 things are there to select, we'll be getting what? We'll be getting confused. Okay. Next is incompatibility exists between software and OS. Okay, there is incompatibility between the softwares. Network condition is also bad, and the protocols are there. There are very different protocols. Which protocol to apply where? That is a very difficult question. Okay. P2P performance is affected by routing efficiency, self-organization by participating peers, and lack of trust is there. What if a peer becomes an imposter? That is not a peer, that is a hacker. What will happen? You are trying to access data from hacker will hack your data and you will be in the loss. Okay, so lack of trust is there among the peers. No one can trust all the computers in the world to be true, right? So that is another problem. The fourth one is the cloud computing. Cloud computing, it's pretty simple. By the name itself you can understand, cloud computing means in cloud all the data will be stored in some virtual server, and the data and computation happens at that place. Okay, that is called as the cloud. In that, all the hardware, software, network, service and storage will be there, and users will pay for the services and utilize the services. Okay, and in that three things are there. The cloud can be as infrastructure as a service, IaaS, or it can be platform as a service, PaaS, or software as a service, SaaS. Okay, infrastructure as a service means what? The whole infrastructure is given as a cloud to the user, means the whole server is given, or the storage or network or data center fabric is given. Okay, and platform as a service, the whole platform is given for deploying the applications. Like Google gives it platform for deploying the applications which the person makes in the Google Play Store. Software as a service, to utilize the software. For example, if the Instagram is a software as a service, Instagram is there, you can post the reels and all. Okay, so that is a service which is provided and we can utilize that service. Okay, so that is a software as a service. And here a few other examples are there, you can go through it. Okay, an internet cloud offers four types of modes: public deployment, private deployment, managed deployment, where you manage what is public, what is private, and hybrid means whenever you want you can switch between each of these. Okay, and there are 8 reasons why you should get a cloud system. Okay, if you are running a business and you do not have a cloud system, you are a waste business owner. Okay, because cloud system will have 8 advantages: the desired location and areas with protected spaces there. What if the your company, there will be a blast in your company? Okay, some server will blast or your data will be wasted, so there is no protection. Someone will come and put fire. Okay, if you do not give them more salary, what will happen? They will go and put the fire and the server will be destroyed, your company will be in losses. So that's why go for cloud. The cloud is protected. Okay, it is not easily accessible by the hackers. Okay, and sharing of peak load capacity. If peak load is there, your server does not support, what you will do? You will tell to the client, my server does not have that much capacity. You will be in a very big insult. Okay, so sharing of peak load capacity should be there. That will be provided by the cloud, because in cloud large amount of data is there. Okay, you can utilize it as and when you need. Okay, separation of infrastructure maintenance duties. You are not concerned about if my server someone is hacking or not. You will be focused on your specific application, what is the value you are providing to the people, right? So that tension will go from you. That is third advantage. Fourth is there will be reduction in cost of computing. Okay, and the programming application development will be faster. Data discovery and services application, everything will be faster. There will be privacy, security, copyright, reliability issues, everything you will be concerned. Whatever you will be concerned, that will be taken from your mind. Okay, service agreement, business model, pricing policies, all will be to your best level. Okay, so 8 reasons are there why you should go for the cloud. Okay, moving to the fourth topic out of the fifth topic, the software environments was distributed and cloud. We have understood the model now. Okay, we have got to know what is the model, what all things should be there, what are the layers should be there. Now we will understand what is the environment in which it should be there. If you put this in an ocean, what will happen? Fishes will eat this one. So ocean is not the right environment for the distributed system and clouds. So which is the right environment? Let's discuss. There are 3 topics here, and this is the most important from the exam point of view. We'll be discussing what I need to remember. Okay, SOA, service oriented architecture. Okay, so whatever the model we have discussed, okay, the distributed model, to deploy it you use a architecture. In architecture there will be different layers. Okay, so the key points are this one: in grids or web service, the entity is Java or Corba. Okay, two are there, Java or Corba, and the architecture is based on OSI layers, and upon the architecture there is an environment in which they run. Okay, 3 points. Fourth point is includes an interface language: WSDL, Java and Corba interface definition language, ideal. Okay, interface definition language should be there to interact with the interfaces. Okay, and the interfaces are linked with high level communication systems like SOAP, RMI and IIOP to have an API call. Okay, and there is a middleware also in that in between, and also they support the features like RPC, remote procedure call, and for fault tolerance, web service reliable messaging is used, WSRM. All of these things are very important. You need to remember and write in the exam from for SOA, okay, service oriented architecture, and this is a diagram you need to make. Okay, there are different layers like physical layer till the grids layer. Okay, this you need to make in the exam for SOA architecture. Okay, the next is the two types of service architecture. Okay, it can be either web service architecture or REST service architecture. In web service architecture, it fully specifies all aspects of service and environment. In REST architecture, it adopts simplicity and delegates most difficult problems to applications. Okay, it is simplicity and delegates. Delegates means many different subcategories will be there. In web, it will be a single thing. Okay, this is a difference. Okay, based on this, you can choose whatever you want. The below figure shows the evolution of SOA, like SOA, how it has developed. Okay, all the services are here and the data is present here. Okay, so what happens? Initially, raw data was there. That raw data was processed to become data, and filtration happens at each level. Okay, and after that data, information is extracted from that. From information, knowledge is taken. Knowledge gives us the wisdom, and wisdom gives us the decisions which we need to make. Right. So this is the evolution of SOA. Okay, and trend towards distributed operating system. Why we are going towards distributed operating system? Because we want fast resource sharing, right? Fast communication. We don't want pigeon to go and deliver our services. We want very fast things, right? To have a distributed OS. That's why we are going for the three approaches for distributed resource management. First approach is build a network of OS. Many OS you build and sell it, you'll earn what? Money. Second approach is to have a middleware which handles little OS and little normal systems. Okay. Third approach is to develop a truly distributed OS, which means it is completely OS, pure OS. Okay. For each of these, there is implementation which has happened. The first one is the Amoeba, second is DCE, and third is MO6. Okay, Amoeba is written in C and tested. Okay, it is microkernel based and it handles low-level processes and memory, I/O operations, and uses a network layer. Okay, DC is the distributed one. Okay, it is a middleware and it is used for the packages handle the file time directory service, security service, and supports authenticated communication. MO6 is the one which is developed by MO6 2, which is called MO6 2. It is a distributed OS, the third one. Okay, pure distributed OS. Okay, it runs the Linux and it using the PVM MPI in the collective communication and processes the control and queuing services. Okay, all these services are provided by the MO6, which are required for the distributed systems. Okay, so Amoeba, DC, and MO6 2 are still in research prototypes that are used in academia. Okay, and MO6 2 can manage Linux clusters or grid of multiple clusters. Okay. Also, you need to understand that there is a transparency in programming between the environments. Okay, data is not bound to specific applications or either of the four layers. Four-layer architecture is there for distributed systems. The first layer is the user data, then comes the application, then comes the operating system, and the last comes the hardware layer. And data is owned by the users independent of the applications. Okay, and data can be moving in between these two, in this all layers, and data can be in any of the OSs. Okay, that is the advantage, and users can choose any OS they want. Standard hardware interface for users to choose different OSs. Okay. Now, there is another concept of the parallel computing. Okay, parallel and distributed are very interrelated. Okay, for that, three things are there, three models: MPI model, MapReduce model, and Hadoop model. MPI model, what it will do? It will run the parallel programs. Okay, it is basically asynchronous point-to-point and collective communication. What it will do? It will pass the messages from one system to other system, and it is used for the I/O operations. Okay, that is MPI. Next is MapReduce. It is used for processing large clusters data. Okay, by reducing it to key value pairs. The third is Hadoop. Hadoop is used to write and run large user application on vast data. Scalable, economical, efficient, reliable tool for providing access for commercial clusters. Okay. And there are grid standards also there. Three grid standards are there. OGSA, which is Open Grid Service Architecture, offers common grid service. Globus Toolkits provides the resource allocations and generic security. IBM Grid Toolbox provides the Linux grid built on top of Globus Toolkit. Okay, grid means what? As I told you, it along with computer, other things of the internet, people, and sensors are involved. For this, what architectures are used? These three architectures are used. Okay. Coming to the last topic of the five topics, performance, security, and energy efficiency. Okay, in distributed systems, performance is attributed to a large number of factors. See, everyone is looking for good performance. One phone is taking 10 seconds to load an app, and another phone is taking 1 second to load an app. Which phone you will go with? This one, because performance is better. So like that only, distributed system also performance is taken into consideration. Whichever distributed system is giving the better performance, that will be taken. Okay, so what are the factors we will be seeing to measure the performance? system throughput, how much output we are getting, how much is the response time, what is the network latency, what is the OS boot time, if we shut down and open, how much time it is taking to open, what is the IO data rate, how fast I am sending messages and getting back the messages from someone, and runtime support and system is used, which runtime support system is used, whether it will be becoming useless after some years or not. All these things are taken into consideration. Okay, and to make it more better, we'll be scaling it. Okay, size scalability, it should be supported, refers to achieving higher performance by more functionality by increasing the machine size. Bigger machine, bigger performance. Okay, software scalability, upgrading the OS to give better performance. Application scalability, matching the problem size with the machine size. If the problem size is more, get a bigger machine. Okay, and technological sustainability applies to the tech changes. Whatever tech changes are happening, it should be able to handle it. Okay, scalable performance is estimated against multiplicity of OS images. Okay, see, scalable performance, what? This is the performance, and if I increase the performance, this will be my performance. Okay, but what happens? OS will be here, and OS images will also increase. Many OS will come. Okay, so we have to see how many OS images are coming for the performance increase. Okay, so scalable performance suggests that system can achieve higher speed. OS images counted by the number of OS images. Okay, SMP means what? Symmetric multiprocessor. It has a single system image. Okay, which could be a single node in a large cluster. Okay, there is a single node in a large cluster. Okay, this is a single symmetric multiprocessor. Okay, here the processing will happen. This thing is used in the scalable performance. Okay, and total number of processors is of 2 order of magnitude greater than the OS images. If OS images is 2 order magnitude means 200 will be the amount of processors. Okay, it is 100 times. Okay, so see, scalability, as the number of processor will increase, number of multiplicity of images will also increase. Okay, in NUMA it is this one, SMP it is this one, grid, cluster, cloud, P2P. So different domains, different values will be there for the multiplicity with the respect to the increase of the processors. Okay, and there are two laws which you need to know finally, which is the Amdahl's law and the ghost. What is that? Gustafson's law. Okay, so Amdahl's law states that speed up factor for the use of n processor system over the single processor system. See, one processor will give me one result. 100 processor will give me how much results? Obviously 100 results, right? So this is one processor, this is multiprocessor. If I increase multiple processors, how many results I'll be getting? That rate of change. Okay, rate of change of me getting the results, that is denoted by this formula. Okay, speed up is equal to this formula, and this formula T is time, alpha is the sequential bottleneck. Sequential bottleneck means if there are three processors, okay, and one task is there, and that task is divided into three parts. If I give this to one task, another to another task, third one I can't give to third task because this is dependent on the second task to complete. Second task will complete, then third task will start. So this is a sequential bottleneck. Alpha is the sequential bottleneck metric. N is the number of processing nodes. If you apply all the values of this in this formula, you will be able to see how much your processor has speed up if you are using one processor or n processors. Okay, but it is not applicable for large cluster. Like if n is 256, this will fail. Okay, it will give very low efficiency. In that, Gustafson's law you have to use. In Gustafson's law also there are terms here, that terms will apply, and this formula will give us exactly if there is a large cluster how much efficiency it will be there. Okay, if it is a fixed workload, smaller ones, you go for Amdahl's law, and if it is a bigger scale problem, go for the Gustafson's law. Okay, don't miss any of these topics, most important from the exam point of view. Please do hit the like button and subscribe to my channel. Thank you so much for watching. I'll see you in the next